Hello, I'm Waffles Are Better. In this video, I'll be showing you how to create custom processors for 1.16 and 1.17 Java Edition Minecraft data packs. Using those, you'll be able to create super cool effects like in this dungeon, where, as you can see, the walls are randomly turned into moss and cracked stone bricks, and all broken with all those stairs and slabs and things. But that's not all you can do. There's also a lot of other things that you can do to modify the structures in your game. They just make them look a lot better. Before I get into this video, I'd like to give a quick thank you to today's sponsor, MCModels.net. Thank you very much, MCModels, for sponsoring another video of mine. I really appreciate it. There is a link to their website and Discord in the description, and I'll talk about them a little bit more later in the video. So for this video, I'm going to be using the same data pack that I used in the fossil structures video. I'm going to be using that same dungeon. So all you need to do to start is create a new folder in worldgen named processor list. So in this folder, just create a new file. This can be named whatever you want, as long as, of course, it follows the file naming rules. Of course, it has to be all lowercase and has to have no spaces or anything. So I'm going to name mine just example_dungeon, which is the same thing I named the configured feature. Oops. Really important, of course, needs to be example_dungeon.json. So in here, just put some curly brackets, and then you're going to want to put in quotation marks processors, and then some square brackets. So this is going to need a curly bracket inside of these square brackets. And then inside of this set of curly brackets, you're going to want in quotation marks processor_type. And there's a list of processor types that you can use. So what's different about processor lists and processor types is there isn't really that much documentation on what all of these things do. The only ones that are actually used by the game, I believe, are block rot and protected blocks and rule. I do know that one of the most common ones that is used is block_rot. This one's pretty simple. All you're going to want to do is put integrity, and this is just going to be a number between 0 and 1. So as I said, there isn't really any documentation on this, but from my experience, and just from logically thinking about this, if the integrity is 0, then it will replace 100% of your structure with structure voids, and if the integrity is 1, it will replace 0% of your structure with structure voids. So like if you did 0.5, that would make it so about half of the blocks in your structure are missing, which would help to make it look like it's falling apart. But I know that, for example, the fossil structure uses this, the default fossil one I mean. What it does is it loads a structure of coal, and then it loads a duplicate of that structure but made out of bone blocks on top of that, except that the bone block structure has a processor on it that turns a lot of the bone blocks into structure voids, which means that they are replaced by the coal blocks in the structure that it generates under that. So that could be a cool thing that you use to randomize which blocks are which, or you could just use it to make it look like your structure is kind of falling apart. So the next one is going to be protected_blocks. And then this is going to have a value. The value is just going to be the blocks that a fossil will not override when generating. So for example, structures will not override bedrock or end portal frames. And I believe this has to be a tag and not a block. So the one that fossils use is Minecraft features cannot replace. And that will protect these blocks from the structure when it's generating. Before I go into the processor type, I'd like to talk a little bit about today's sponsor, MCModels. Since they've sponsored me before, I've talked about how cool I think their site is before. MCModels is a website that has a store where there are quality controlled things like 3D models for creating servers, They've also got resource packs and maps and data packs and a ton of other stuff. And all of those things are really good quality and great if you want to start a server and add some cool fun things to it. But that's not all they have. They've also got a bunch of tutorials on how to make resource packs and models and data packs and stuff like that. And I'm helping to write some of those, so more of those tutorials will be coming soon. As I've said before, I wouldn't accept a sponsor or promote anything that I didn't think was really good and helpful. And I do think that MCModels is a really good, helpful site, and they've got some really cool stuff on there.
Hello, welcome to MCModels, your one-stop shop for all server resources. We have everything from custom item models, schematics and mythic mobs bosses, to model engine mobs, decorations and NPC voice packs. If you've never used custom models or need help with model engine, we have easy-to-follow tutorials on a ton of subjects, as well as great community support and commission requests on our public Discord server. What are you waiting for? Make your server better today.
Alright, that's all about MCModels. You should consider checking them out. There's a link to them in the description. And let's get back to the video. Then this last one is the one that's most commonly used, and you're probably going to want to use it the most. This is going to be the rule processor type. And basically what this does is it just specifies several rules for blocks that should be replaced. So you're going to want to type in quotation marks again down here, rules, and then a colon, and then some square brackets. And then inside of these square brackets, you're going to want curly brackets. Then the first thing you're going to want to put is input underscore predicate, and this is going to be the block that's going to be replaced. So you're going to want to put predicate underscore type. This is usually going to be random block match. And so if it's random block match, you're going to want to put block, and this is going to just be the name of the block. So say you want to replace stone, all you have to do is put block stone and then probability, and this is the probability it has to replace any given stone block. So if you put 0.3, then of course it'll have a 30% chance to replace any stone block in your structure with the next thing, which is going to be the output state. This can also be always true, which is probably not what you're going to want to do, because that is going to just replace all of the blocks. It can be block match, which is the same as random block match, except without probability. It can be block state match or random block state match. So random block state match would just be, instead of the name of the block, you would put block underscore state, and then a curly bracket. Oops, and you're going to want a comma after this curly bracket. And inside of the curly bracket, you're going to want to put name, and oh, and I forgot a comma up there. Wow. And then of course the name is just going to be stone if you want to put a stone block, and then you can put properties if you need to. So what this would do is target any grass block that has the property snowy equals false. And of course, if it's just block state match, you would delete the probability because you don't need that because it's not random. And then the last possibility is tag underscore match. And in that case, you would just delete all of this and also delete probability. And instead it would be tag, and the tag would be just either one of the tags that's in the game or a custom tag. And so it would replace any block that fits into that tag. And that's about it. So I'm going to change this back to random block match, and I'm going to make the block, let's just say stone bricks, and the probability is going to be maybe 50%. Oops, except that would be 0.5. And so that is all of the input predicate stuff. You're then going to want to put output underscore state, and I forgot an A there. I'm really bad with my typing today for some reason. This, well, it auto-corrected to Minecraft Stone. It's just going to be a block state provider. So, for example, Could be name equals Minecraft stone. Could also be name Minecraft, I don't know, oak log, and then properties, axis is Y. So just remember that you need to put properties there if you want to put properties. But for my output state, I want 50% of the stone bricks to be replaced by cracked stone bricks. And the last thing that you're going to want to put is the location predicate. And what I believe this is telling it whether to actually do this depending on what block is already there. So for all of the processors in vanilla Minecraft, I believe that the predicate type is always underscore true, which means that if the block that's going to be generated in the structure is stone bricks, it will be replaced by cracked stone bricks 50% of the time, no matter where it is. But, for example, if the structure was generating underwater and you only wanted to replace the stone bricks that would be replacing water with cracked stone bricks, then what you could do is instead of putting always true, you could put block underscore match and then put block water. That would mean that if the structure is generating a stone brick block in water, then 50% of the time that stone brick block will be replaced by cracked stone bricks. And of course, predicate types are the same as the ones I went over for the input predicate. And I believe that that's what this is. I didn't find that anywhere. It's not anywhere in Minecraft Wiki or in any videos I saw or anything, because I can't find anything on this. But logically, that is what this is. And it's pretty hard to test because you can't really control where this structure is generating exactly. But to the best of my knowledge, that's what this is for. Then the last thing, this one's optional, is position predicate. And I know that what this does is it basically creates a higher chance of this predicate being applied depending on where in the structure the block is. But I don't exactly know what everything in it does. So predicate type is going to be either always true, access to aligned linear pause, or linear pause. So I think always true just is useless because it would make it be exactly the same through the whole structure, which wouldn't change anything at all. So access aligned linear pause and linear pause are basically the same thing, except with access aligned linear pause, you do need to specify an access. So that would be axis, and then this has to be either X, Y, or Z, depending on the dimensional axis that you want this to be applied. So I'm just going to choose Y because I want it to be up and down. And then max underscore dist. And I'm just going to leave this at 0 for now. Then min underscore dist. And I'm going to leave this at 0 too. Then max underscore chance. I'll leave that as 0, and min underscore chance, I'll also leave that at 0. I do not know what exactly the numbers for max dist and min dist means. That means the height inside of the structure, or it means total worldgen height. So for the processor that's actually in the game that uses this, I believe the max distance is 100, and the max chance is 0.5, I think. Maybe it's 0.05, and I'm pretty sure that what this means is at a distance of 100 up the y-axis, there is a 5% chance to turn the input predicate into an output state following the processor type. So basically at a distance of 100, there's a 5% chance for any of this to actually happen, and a 0% chance at the minimum distance, which is 0, which means that it gradually gets more and more likely to happen. However, I don't actually know what the max distance and min distance actually mean. So as I said, this could be the min distance is block 0 and the max distance is block 100, or it could be this is 0 blocks up the structure and this is 100 blocks up the structure, or it could be something else that I am not aware of. This could just be percent-wise. It could be like, this is 0% up the structure and this is 100% up the structure. But sadly, I can't find a source anywhere on what these two mean. So this is basically all you're going to need for the rule processor. You can add more rules if you want to. You could copy all this and then just paste another one like this. Just add a comma and then paste it. If you want more rules, and again, you're probably going to want to make this location predicate always underscore true, because that's what the game usually uses, but you might want to use something else. And you don't need the position predicate if you don't want to do anything based on position in the structure. All you really need is an input predicate to say which block you want to replace, an output state to say which block you want to replace it, and then a location predicate to tell you, I believe, when it will replace that based on what block is originally in the position. Alright, so moving on to some of the simpler ones, I'm going to change the processor type to block underscore age and add a comma. And for some reason, the value here is going to be mossiness. It has to be between 0 and 1, and this one's actually one of the most helpful processors in my opinion, even though it isn't used by any of the structures in game. Although now that I think about it, it's probably used by dungeon features and stuff. Because what this does is, depending on the mossiness, so for example, if you put the mossiness as 0.5, that would make half of the blocks in your structure aged. So mossiness doesn't exactly mean mossiness. For example, it'll turn stone bricks into either mossy stone bricks or cracked stone bricks or stone brick stairs or stone brick slabs, just to make it look like it is older. And I don't know if it does it with other blocks, but stone bricks is what I tested it with. The next one is going to be block underscore ignore. There isn't a source for this anywhere. I'm just doing my best to figure out what all these things are. That's going to be blocks, and then square brackets. Inside of the square brackets, you're going to want to put curly brackets, and this is just going to be a block provider. So name stone, for example. And the only thing that I can think of this being is something similar to the protected blocks that I went over earlier. Since protected blocks is a tag, maybe this is a way to do it, but with blocks, I don't know. And then the last one that has any config to it is going to be the gravity one. So it's going to be processor type gravity, and all you have to do here is put a height map and an offset. So, of course, the available height maps, I've gone over them before in a different video. There's the world surface for worldgen, and there's world surface, ocean floor for worldgen, and ocean floor, motion blocking, and motion blocking no leaves. I'm just going to put world surface WG, and then the offset is just going to be a value between 0 and 1. It's probably how far it's allowed to be from the actual height map. And even though I don't know exactly what the offset value does, I know that this is a pretty cool processor. It basically does the same thing as setting the projection type to terrain matching. In a template pool, it will put your feature on top of the terrain, or actually on top of the height map, and so basically it'll match it to the terrain. So like if it's on a hill, it will, be kind of hilly. The actual structure itself will be bent to the shape of the terrain. So the next one that I'm going to go over is going to be jigsaw replacement, and I don't actually know what jigsaw replacement does. There's no config for it, and there's no explanation for it that I could find anywhere. What it could maybe be is it replaces jigsaws with what they're supposed to be without actually generating the jigsaws themselves. But I really don't know for sure what this is supposed to be. So then next is lava submerged block, and this is again something that does not have any config, and I don't really know what it does either. And then the last one is nope, and I'm pretty sure this is just a placeholder and doesn't actually do anything. So I guess what I want to do is use the block age one, and I guess mossiness should be about 0.5. And you do need to make sure that if you're using a fossil configured feature type, you're going to need to put it in the fossil processor and overlay processor if you're using both of those. And switching over to my frost data pack as an example, if you want to put that processor in one of the structures that you have that is generated by a template pool, so a configured structure feature, that is just going to go in processors inside of the element. So for example, I would change this to example and then example underscore dungeon to make that processor generate. But that's not what I want. I want it to be Minecraft empty. So I've gone ahead and loaded up a world with my feature in it that now has the processor type that I just created. Of course, it's not on the surface because it is a fossil and I made it generate underground. But if I fly down here, I should be able to see one pretty easily. Oh, there's one right here. Well, that was pretty easy. If you remember from my last video where I actually built this structure, it was basically just a stone brick box, and there wasn't any cracked stone or mossy stone or anything like that. There were no stairs mixed into the walls, and there were no slabs mixed into the ground. Since I just added that one processor that aged the blocks, there's now lots of mossy stuff and cracked stuff, and it replaced a bunch of the blocks with stairs and slabs. What's cool is that every single one of these will have a different pattern of cracked and mossy bricks and stuff. So as you can see, in this one, there's a stair like this right here, and it's mossy. But if I go over to this one, that stair is not mossy. And there's a different pattern of moss up here. If I look at these two stairs right there, I'm going to say, yeah, they're not here. These are not stairs in this this version of the feature. So that is a pretty easy way to add some randomization and better detail to your structures. That's it for this video. If you have any questions about anything I covered in this video or anything you want me to cover in future videos, you can talk to me in the comments of this video or in my Discord server, which will also be linked in the description. We reached 450 subscribers since my last video, and I'd like to thank every single one of you for that. I really didn't expect to get this far, and I know I thank you guys at the end of every video, but just thank you guys so much. I really appreciate it. And thanks again to MCModels.net for sponsoring this video. I really appreciate them too. Thanks for watching.